Alright, on to the final page, the page 5 portion of it. So these are a continuation of conic sections, and what you have is standard form. You're trying to get into standard form from this non-standard form. You want to be able to tell what it is right out of the chutes. These are both squared, x and y, and they're both the same sign, so it's an ellipse. From there, then you want to focus on getting it into standard form of an ellipse, which has the plus sign, these binomials squared, etc. Things that you have on the formula sheet for conic sections, and you'll have it on the test as well, so you kind of know your goal. So if I go back here a little bit, hang on just a second as I delete a little of this, I can see a little better. Now, the first thing is you want to group x's and y's, and that means just putting your x terms and y terms together with a plus sign between them. There's no need to do any factoring at that point. Then, as soon as you get your grouped x's and y's, you can't complete the square unless the coefficient on the x squared and y squared are 1, respectively. So, for the first, you want to factor out a 4, leaving behind the 6x. You want to factor out a 9 on the y term here, leaving behind the y squared and the negative 4y. So these are just getting the stage set for completing the square. And let me talk about completing the square now. And completing the square, remember it's half this middle term squared and added, that's why you see 3 squared here, allows you to rewrite the trinomial that you see in parentheses here as x plus 3 quantity squared. And the plus 3 is the half of the middle term that you see right there. Okay, and the 4 tags along, still there. And then on the y portion of it, half the middle term, half of negative 4 is negative 2, square it and add it. And what you want to do from there is then rewrite that trinomial as half the middle term, which is the half of the negative 4 quantity squared, which you see right there. Now, there is a little error that it was on the key that was posted, and you want to be careful. This didn't have any compensation, I don't think, for the variables that were added. So, for instance, what we're missing is when we completed the square on the x term, didn't take and adjust, let me get these in here, that 4 times 3 squared needs to be added to the other side, so we want to add plus 4 times 3 squared out here to the other side, and the 9 times negative 2 squared didn't get added to the right hand side of it, so you want to make sure you add plus 9 times 2 squared. And maybe it does, and I'm just not seeing it on there. But with those additions, you're going to see a different value on the right-hand side. And I think that right-hand side maybe it was, I didn't know if you thought it was a guess or something like that, but it does happen to be positive 36. I was just concerned that maybe it was a lucky guess or a mistake that made that key happen. So I went ahead and put in the work that shows the compensation. So hopefully that wasn't an error, or you didn't think it was some lucky guess or the negative was dropped. But it comes from adding the 4 times 3 squared and the 9 times negative 2 squared that I've highlighted back before that. So it should be a positive 36. Now, if you keep an eye out for this, this is when you had that positive 36 on the right-hand side. That's not quite standard form. You want to divide by 36 on both sides so that that right-hand side is equal to 1. That's a key component of standard form, is that the right-hand side of the equation is equal to 1. So this 36 that's sitting right here needed to be turned into 1, and the way you do that is to divide by 36. And everything gets divided by 36. And then these little fractions, you can't have a coefficient, you can't have that 4 next to x plus 3 squared. So you got to simplify that fraction to 1/9. And you cannot have 9 over 36, you got to simplify that to 1/4. And so finally, you get what's over here on the right-hand side. I'll put a box around it. Now, there was a 9 here, and there is a 4 here, but what's best is to write those as a number squared, a value squared, so 3 squared and 2 squared respectively. So should you have to sketch something like that, you know that if it's under x, it goes left and right, and if it's under y, it goes up and down. So the next, completing the square, assuming that you kind of get the idea, I'm going to let that one just kind of explain itself, because I think everything's good. It looks like there is positive 1, and then let's make sure that completing the square stuff happens. I'm going to show that, document that. When you add 1 squared there, that means from this side over here you want to add 1. And on the other one, as you are completing the square, on the second half part of that, looks like you group the y's. Oh, we do have a little error going on here. This should be a positive 2, because here's what happened when we group the y's. they are both, so let me maybe back this up a little bit. We have a sign issue that's taking place in this particular key. So this particular student work that I used, the grouping of the y should be negative y squared minus 2y, and that means when you factor out the negative 1, which we see here, underlined, that I just highlighted, it'd be positive y squared and a positive 2y, and then you complete the square. The only effect that really has is half that middle term would be a positive 1 here. You'd still be, you also want to distribute that negative, so when you take what you're actually adding to the left-hand side of the equation is a negative 1, so you also want to add a negative 1 to that side, so I did it in green there. So that'd be 1 plus 1 and then take away 1 again. And I hope everything else is okay. So this one ends up actually being equal to 1 because these two cancel, negative 1 and 1 and cancel, and you get, or actually 1 and 1 makes 2, take away 1 gives you 1. So this was already equal to 1. You didn't have to divide by anything. So let's cancel those dudes out right there. There's the appropriate answer. X minus 1 quantity squared minus y plus 1 quantity squared all equal to 1 by doing the compensation stuff and properly factoring. So remember the errors here, we're not distributing that negative. And also when you group the y's and you factor out a negative that I've shown up here in parentheses, see if I can start here in green so you can follow what I'm talking about. If you take a negative out of both of those, it'd be y squared plus 2y, and then you go back completing the square. So a little adjustment on that one. We'll cross that little dude out, that's plus, that's still minus there, this is just 1, and that's 1 as well. Okay, let's keep on a roll. It looks like we have all our limits look okay. If you have any argument on any of these at this point, it'd be a really good time for you to say something, bring it up so that we can make adjustments as necessary. That's page 5, part 1.